when we actually this section 1.5 is all about solving inequalities, right? Graphing them and putting them into interval notation. Just to recap, one thing you have to be careful about when you're solving inequalities is when you multiply or divide by a negative number. What do you have to do? Yep, you got to flip the sign, right? You got to be careful with that with inequalities. And then the new thing for Algebra 2 compared to Algebra 1 is interval notation, right? Interval notation deals with parentheses and brackets. And this little box here tells you the difference of whether to use parentheses or brackets when we're putting in an interval notation. Parentheses, there is no equal sign with our inequality sign, and with brackets, we do have the equal sign with our inequality. And then yesterday I talked about an open circle when we used to graph in Algebra 1. We have to, when you're solving inequalities, just like equations, you have to get x by itself or whatever the variable is. Time. Here we have x is by itself, so then we go to graph this. You put 3 in the middle, 1 greater, and 1 less. And yesterday I was showing you that we used to put, like this would be an open circle because of the no equal sign. Well, in Algebra 2, we're going to use brackets and parentheses. So this would have a parenthesis because there's no equal sign at the 3. Now I want all those numbers less than, so I'm going to face that parenthesis to negative infinity. And I'm going to shade this side of the graph. That's the way we're going to do it in Algebra 2. And the interval is the smallest number on the left-hand side, which is negative infinity. Okay, and the graph shows that it stops at the larger number 3. Now, infinity always gets a parenthesis because you can never include the point negative or positive infinity. Now, be careful with the larger number 3. It has the parenthesis because there's no equal sign in my inequality, and there's my interval notation. I think everybody was pretty good with that. Okay, with number 2, the second example. Okay, I've got the numbers -2 was in the middle, and then one larger, -1, one smaller, -3. This time it has a bracket because of the equal sign at -2, and we want all those numbers greater than -2. If you don't know which way to shade, as long as your variable is on the left-hand side, you can just follow the arrow. So I'm going to put my bracket at -2 because of the equal sign. I'm going to shade, and you don't have to put the infinity signs on the number line. I do because it's easier to put the interval notation. All you have to do is just copy that to interval where the notation is, and again, parentheses on infinity. Notice, and I don't know if it was this class or another class, notice negative infinity always goes on the left for the least number. Positive infinity always goes on the right because that's the largest number you can have. Okay. Then we went ahead and solved some of these. Let me just redo number 2, okay? I know you guys, we did this yesterday, so hang on. There were some people absent. I'm going to, first, just like an equation, I have to get x by itself. So we subtracted 5 from both sides. These added up to 0. I get negative 2x greater than or equal to 22. And then I divided both sides by negative 2. And we got x and negative 11 on the other side. But because we divided by a negative number, we had to flip our sign, right? And then we graphed it. The negative 11 goes in the middle, one bigger, negative 10, one smaller, negative 12. Bracket because of the equal sign. And I'm going to follow the arrow or all those numbers less than negative 11 goes to negative infinity. Interval notation, smallest number always on the left, larger on the right, parenthesis with infinity, bracket with negative 11 because we included it. Everybody good so far? I think everybody was good at this point. Then I started losing some people here, right? When we have a variable on both sides, should we be a little different in number 4? Okay. So I have to, just like an equation, I have to solve for x. So here's my dotted line, as if that's an equal sign, but it's not, it's less than. I need to get my x's on one side. Now, yesterday, I told you things are just easier if you can leave the variable on the left-hand side. Normally, I would always keep my variable term positive, right? I would subtract 2x. But believe it or not, I kind of like break my own rules here with inequalities because it's easier to graph. So I'm going to subtract 6x from both sides, leaving my variable term on the left-hand side. 2x minus 6x, negative 4x, plus 1 is less than, these equals 0, negative 1. I'd rather deal with negative number than switching my x from the right side to the left side. Okay, I'm going to subtract 1 from both sides. Subtract 1, I get negative 4x is less than negative 2. And now, to get x by itself, I have to divide both sides by negative 4. So I get x. I'm dividing by a negative number, so I'm going to flip that sign. Negative 2 divided by negative 4 is positive 1/2. This is easier to graph than this. I can't even write it because it gets confusing. This is kind of, I tell you, 90% of students make mistakes when they go to graph this. Okay? The same thing as this, it's just flipped around. That's why I like to leave my variable term on the left-hand side, because I get to graph this and not that. If you run into a situation where your variable is on the right-hand side, you have to flip everything around to graph it, to avoid making mistakes. Okay? I'd rather deal with negative numbers than messing with the x or variable term on the right-hand side. Okay. This 1/2 goes in the middle. I need a number larger than 1/2. 1 is bigger than a half. Number smaller than 1/2. 0 is smaller. Parenthesis at 1/2 because there's no equal sign. And I want all of those numbers greater than 1/2. And that's going to go out to positive infinity. Positive infinity is always on the right-hand side with a parenthesis. Means 1/2 goes here, and we are not including it because there's no equal sign. That helps clarify a few things. You solve it just like an equation, but just with inequalities, and you have to watch for that multiplication by a negative. And I believe that's as far as we got yesterday, correct? Uh-oh. You can look and line. Oh, that's better. Do you need to sit closer? Oh, wow. So it's more like colorblind. That's kind of weird. All right. We didn't do compounding inequalities, correct? Did we? I rushed through it. Okay. Let's take our time today. Compound inequalities. Now, yesterday I was telling you about the less than sign being an and greater than being an or. Let's forget that. Okay? Now, here's the thing. When this is actually a condensed version of and, when they have no conjunction word in there, like or, they separate it. My conjunction word is or, right? Here, there's no conjunction word and. They squished everything together and threw out and. This can actually be rewritten as -2. There's the compound. The word itself means that there's 2 inequalities. And you look at this and you're thinking, well, there's only 1 inequality. But it's not. There's 2 inequalities. They just combine them all into one statement. This actually says -2 is less than or equal to x, and x is less than 1. See how they just took out the word and squished it? Okay. Whenever you see an inequality statement with no conjunction word, it's an and problem. Just going to have to remember that. Okay? And the graphs for and problems. The graphs for and problems are always going to look like, well, either a bracket or parenthesis, and it's always going to be shaded in between, right? Okay, so you ever see one of these two, and these could be greater than signs. They can be greater than signs. Or one's greater, can one be greater? And I don't think so. So I think they both have to be the same way. Either one of these is going to be a graph like this for and problems. For or problems, we have a couple of different situations. Okay? or problems, generally the graph is going to go opposite ways. So I have my negative infinity number line that goes to negative infinity and positive infinity. I'm either going to have a bracket or parenthesis, and it's going to shade towards those infinities. Okay, so that's our OR graph. Now, this is going to be 90% of the time. You're going to have an OR graph, and you're going to have this situation. I think some call it rabbit ears or something. Bolt ORs, I heard, like growing up OR. You do whatever you want. 5% of the graphs for OR problems is when we have this negative. Is when we have, suppose I have one of the inequalities going this way. I could have another inequality going the same way at a different number. So 5% of the time we can have this happening. And you would only end up with one inequality instead of two. And then the other 5% of the time, and this I know you're going to run into. I know it's on a worksheet somewhere. Maybe even a quiz. By the way, we're having a quiz Friday. Okay, so we have our bracket parenthesis going this way, and then we have another bracket or parenthesis going the other way, and they kind of overlap, right? And what is my solution when they overlap like this? What numbers are always shaded? All of them. So we put the solution all reals. Okay. And when you get into higher math classes, this is the symbol for all real. Double bar R. Double bar R. So you can just put that down for all reals. And for Grace, you're probably not going to see the double bar. And then I really rushed through an example problem, didn't I? Ready? Good with this? Yeah, this, you should have done this in Algebra 1. Yeah. We really, we have yet to learn any Algebra 2. The only thing that might be different is integral notation, but there are some Algebra 1 teachers that teach integral notation. Oh, you did that in Algebra 1? Which one did we do yesterday? 8, so let's do 9. Okay. I know this is an and problem. 2 reasons. They tell us. But there's no conjunction word, right? Conjunction. So I know it's an and problem. It's a squished and problem. I could separate this and solve them separately if that's your preference. But it's almost easier to just solve it when it's squished together. Okay, I'm going to put a dotted line here for this inequality. I have to solve that one. And then I'm going to put a dotted line for that inequality. I have to solve that one. So I have 2 of them. It's just condensed. Okay, I still have to get the x by itself. So I'm going to get the x term by itself by adding 3 to both. Well, if I look at it this way, I have to add 3 to both. And if I look at this inequality, I have to add 3 to both. Okay. Negative 12 plus 3. Negative 9. I'm adding, so nothing, the inequality sign stays the same. These add up to 0. I have my 3x. This stays the same. 15 plus 3 is 18. Then I have to divide by the coefficient 3, divide by the coefficient 3, divide by the coefficient 3. Negative 9 divided by 3, negative 3, x. I'm dividing by a positive number, so the sign stays the same. My x stays the same. 18 divided by 3 is okay. Let's put our negative 3 in there and our 6. Just pick any bars, I don't care. I know that it's an and problem, so it's going to be an in between. So in between those numbers are going to be shaded. See, negative 3. Negative 3 gets a bracket because of the equal sign. And the 6 gets a parenthesis. And I shade in between. And problems are pretty easy for interval notation because you're just going to take this and put it down here. So I have my bracket, negative 3, comma, 6, parenthesis. That's my interval notation. Now, OR problems are actually just a little bit harder. Which one did we do yesterday? We didn't do one? Didn't do any of them? Oh, well. Okay. Let's pick one. Let's do number 11. Okay, it's OR. It's an OR problem. So we know that the graph is going to look like 90% of the time like that, right? Opposite way. So we've got two problems here. We have to solve for this inequality, and we have to solve this inequality. Okay. I'm going to subtract 3 from both sides. I get 2x is less than 2. Then I'm going to divide by 2. So I get x is less than 1. Or, okay, solve the other one. I add 7 to both sides. I get 4x is greater than 16. Divide both sides by 4. And I get x greater than 4. So pretty straightforward OR problem. Put my numbers here. Let's see, small number on the left-hand side, large number on the right-hand side. Both of them have parentheses, right? This one's going to go to negative infinity, and this one's going to go to positive. Again, you don't have to put the infinity signs on the graph. Interval. Well, I need two intervals because there's two separate ones, right? So I have negative infinity, comma, 1. Infinities always get parenthesis. The 1 has a parenthesis. My 4 has a parenthesis, smaller number, larger number, positive infinity, parenthesis. Now, I don't know what grade they taught Venn diagram. They used to teach it in elementary back in. But this is an or. Remember, it'd be in one circle or the other circle, and the symbol for that was the union of the two circles. That's the symbol we're going to use for or. This is my interval notation for problems. Are we good? A little more sense today? Want me to do another one? Yeah, let's do another one. Let's try 13. Then I'm done because I'm really losing my voice today. Okay, we have two inequalities that are OR compound. So I know my graph is going to go opposite ways 90% of the time. I'm going to do the first one here. I'm going to subtract 7 for both sides. So I get negative 2x is less than or equal to, stays the same because I'm subtracting, negative 4. Then I'm going to divide both sides by negative 2. This time I have to do what to the sign? Flip it because I'm dividing by a negative number. And I get 2. Now this inequality, I'm going to subtract 5 from both sides. I get 3x less than 2, or negative 2, right? 2 minus 5 is negative 2. And then divide by 3, divide by 3. This should be negative 3. Okay, so I get x is, now I'm dividing by a positive number. Even though I'm dividing a negative number, I'm dividing by a positive, so I keep the sign as is. Negative 3 divided by 3, negative 1. Okay, let's graph this. My smaller number is what? Negative 1, so that goes on the left-hand side. My larger number is 2, so that goes on the right-hand side. My 2 has an equal sign. It's a bracket without the positive infinity. My negative 1 gets a parenthesis, no equal sign, and that's going to go out to negative infinity. So my interval notation, negative infinity to negative 1, both have parentheses, union, my bracket 2 to positive infinity. parentheses. Got it? Now you should be able to do the book work. Now, the book work. Okay, the book work assignment for this, I copied it here. Be careful. I gave you the answers on the back, right? They're not going to be the same answers that you guys are going to do because this does it the Algebra 1 way where they have open and closed circles. They don't have interval notation, but it gives you an idea of what the answer should be. You're only to do these problems 15, 17, 21, 23, 37, 39, 41, 43, and 59. I think that's what, 9 problems. And I want you to solve them, graph them, on the number line with interval notation, and then write the interval notation. So just like my example problems. Solve them, graph them with interval notation on the graph, as well as the interval notation statement. Okay? Find this? Got 6 hours to do this, and good luck. You guys get out at 3:30, right? Yeah, no humor in the morning whatsoever. None.